Hi, everyone. Just wanted to take a couple moments to talk about um, proofs involving triangle congruency. In particular, in this video, I'm going to be focusing on angle, side, angle, and angle, angle, side. And I understand that if you were in a situation where you were having to just do one of these proofs, you would not necessarily know if it was angle, side, angle, or angle, angle, side, like exclusively. But I'll go over a couple ways you can kind of eliminate side, 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 and side, angle, side pretty quickly from these. So let's get started with this first one. So we are given that segment AB is parallel to segment CD and that segment BD bisects segment AC. Okay, so we know right off the bat that parallel lines are only ever going to give us congruent angles, right? We know that, we have alternate interior, alternate exterior, corresponding, things like that. It's not going to give us anything about side length. So we kind of know that that's not going to help us with side. We do know that BD is bisecting AC. Since only BD is bisecting AC, we cannot say that AC is bisecting BD at this point. Um, so we only know really one way to get a side. So we only have one set of sides that we can directly come up with, and that's from this. Sides are very hard to get. You pretty much are going to have to deal with either a segment bisector or a midpoint. Beyond that, it's just if it's given to you. So that pretty much means we're only going to get one set of sides. So therefore, we're going to be stuck with AAS or ASA. All right. So if we look at this, let's go through what we have. We'll start our proof. All right, so we have our statements and our reasons. I'm just going to write down our givens first. So we have AB, segment AB is parallel to segment CD. Again, you could insert an equation and do the overline for that. You can also just write segment bisect. Whoa. Okay, again, you could have split this up into two, but I'm going to write it as one. All right. So, well, what do we know about the parallel lines? Well, they're giving us some angles that we know must be congruent, right? Because these are transversals. So because of alternate interior angles, we can say right off the bat that we have some sets of angles that are congruent. So I'm going to say, and I'm going to use all three letters to specify which angles I'm talking about. At this point, A, B, and then D and C and whatnot, it's pretty clear, but I just want to go through the process of writing all three letters. So EAB and then ECD. All right, and then we also know that angle EBA is congruent to angle EDC. All right, so we do know that, and that just comes from the alternate interior angles theorem. Right, and that we're able to do that because we know that the lines are parallel. Fun fact, if you are ever given triangles like this and you didn't necessarily know they were parallel, if you were able to prove that they were congruent, you could use CPCTC and then actually show that the lines were parallel. But that's not this proof. So let's focus on what we have left. Now, if I really wanted to, I could supposedly, I could use vertical angles, but that doesn't help me, right? That gives me three angles. I still need a side. Well, we know this is going to give us our side. We know that if BD is bisecting AC, well, we know that AE, we know that must be congruent to CE. And that's really just what we're getting from being a bisector. All right, so that's kind of our bisector. It's putting it into two different parts. A bisector, but when it's cut into two different parts, they're both congruent because they're equal. Now, what are we doing here? Well, we now have this side and that side. So we have a side, an angle, and an angle. So we do have angle, angle, side. Okay, so we do have angle, angle, side. And luckily, it tells us what exactly the congruent statement is, so we don't have to try and make sure that we really write the triangles in the letters in the right order. All right, so because we had our angle, and our side, and the side was not between the two angles, we are able to say this by angle, side. Okay, so let's move on to the next one. What do we have here? Well, we are given that BD, segment BD, is bisecting an angle, and we are given that BD is bisecting another angle. So right off the bat, we have two angles, right? I mean, when we're bisecting angles, we're dealing with angles. So we can easily see that this is going to be a situation where it's going to be either angle, side, or angle, side, angle. And look at that, we share a side. So bam, we already know our flexor property. I know where my side's coming from. So let's work from there. Also, we look at this and say, well, we have these two. This means that I'm going to be CP-CTCing, right? If we are ending with something other than the triangle congruence, we are going to be using CP-CTC. So we have our statement and our reasons. Statement, reason. Now, let's just start with what we're given. So we know that BD is going to bisect angle ABC, and we know that BD is also bisecting angle ADC, and that is what is given to us. Okay, so BD is bisecting ABC, which means that these two are the same. And this BD is bisecting ADC, so that means these two are the same. So let's just, this is a situation we really do need to be specific, right? If I just wrote angle B, well, which way angle am I talking about, right? So I do have to say angle ABD is congruent to angle CDB. And I also know that angle ADB, is congruent to angle CD. Oops, sorry, that should have been a B. ED. CDB. Let me just clean that up. Sorry. BD. Okay. And well, what's that? That's just what it means to be an angle bisector, right? We know if it's an angle bisector, it's going to cut it into two congruent parts. Okay. Well, what do we have now? We have these sets of angles, but we also know that we share a side. So we can just get our side right now. BD is congruent to BD. Whenever we get to write that, that's easy enough. That's going to be our reflexive. Okay, so now we are given a side, an angle, a side, and an angle. So the angles kind of are on the other ends of the side. So the side is in between them. So we know immediately that these triangles are congruent by angle, side, angle. All right. Now we do have to set up our congruent statement correctly. So we're going to do A, B, D, and CBD. A, B, D is congruent to triangle CBD. Okay, so you do need to be careful. Obviously, in this one, they kind of line up pretty nicely, but it is possible for you to have like the B line up with the D and the D line up with the B, things like that. All right, so now what do we have? Well, we know that these two must be congruent for the sheer fact that once we said that the two triangles were congruent, we can use CP-CTC. Right? Whenever you're dealing with two triangles and then you have something else being congruent, there's a good chance you're going to use CP-CTC. Okay, and we are able to say that by CP-CTC. So these are some pretty common types of proofs that you can encounter in the event that you are dealing with triangle proofs. So please let me know if you have any questions. Have a great day.